Section 5.2 is another section on solving systems. Yesterday, what we looked at was solving systems by graphing. And the thing about graphing is, one, it tends to be inaccurate. A lot of the ones that we looked at yesterday, they crossed on nice, neat points like 2, -3. But what if the answer was like 1 2/3 and 2 5/8? That's kind of hard to get exactly right if you're estimating where the graph crosses. So luckily we have ways that we can use algebra to solve these instead without having to do all those extra steps of graphing and without having to make any estimations. So the first method that we're going to look at for solving a system of equations is going to be substitution. So here's what we are going to do. In order to use substitution, the first thing that you need to do is solve one of the equations for one of the variables. Now this can be x or y. It does not have to be just y. We're so used to doing y equals mx plus b, but you can solve for x if you want. Now, really, the only time that you would ever want to use substitution, because we're going to learn another method in a little bit, the only reason you'd ever want to use substitution is if one of the variables is already by itself. Otherwise, I would use a different method. But so what we're going to do is we're going to use the substitution property to take the value or the expression that you get from step 1, and we're going to write that in place of the other variable in the other equation. Then we'll go through the next steps after that. But let's look at what I mean by this substitution step. So if we look here in number 1, the first thing we want to check is one of the variables already by itself? And it is. Y is by itself. And what it tells us is that y is equal to 3x plus 2. So in the second equation, we can take out the y and we can replace it with 3x minus 2 since we know that that's what y is equal to. If we know what x is, then we can get a number for y. We don't have to know that y is a number. All we need to know is that these two things are equal. And that allows us to say anywhere that there's a y, I can take it out and replace it with the 3x plus 2. So that's what we're going to do. So we're going to rewrite this second equation right here without the y in it. So this is going to be 2 times whatever y is instead. And so again, what we are going to use is we know that y is equal to 3x plus 2. So we're going to put 3x plus 2 in here. And now if you look at our equation, we have only x's. When we started before, up here we had x's and y's, which makes it unable for us to solve. So when we get down to just one variable, either all x's or all y's, then we can solve it just like we would any other equation. So the first thing I need to do is distribute. So I get x plus 2 times 3x is 6x, and 2 times 2 is 4, and that's still equal to 11. Make sure that you don't forget to multiply the second number. A lot of you guys forgot that on your equations quiz. And the other thing that you want to make sure that you do is don't right here try to like subtract x and subtract x. I saw that from a lot of people. All we're going to do is, since these are like terms, we're going to combine them. If I have 1x here and 6x is here, when I add those together, I have a total of 7x's. Plus 4 equals 11. And so now all my variables are on the left, which means all my constants have to go to the right. So I'm going to subtract 4 from both sides. That leaves me with 7x equals 7. And so then when we divide by 7 on both sides, we get that x is equal to 1. If you need to take a second to copy this in your notes, go ahead and put the video on pause until you get caught up. So what we just did was step 1, we got a variable by itself. Step 2 was to substitute into the other equation and solve for the variable. Now we're on to step 3. Step 3 says substitute the value you found in step 2, that was x equals 1, that's what we just figured out, into an equation with both variables and solve. Here's the thing. It doesn't matter which of these two equations we plug into. We just have to plug into one of them, and we're trying to solve for y. Since we're trying to solve for y, and in the top equation y is already by itself, that's the one that I'm going to plug into, but it would not be wrong to use the other one. So now that we know that x is equal to 1, we're going to take out the x and this time replace it with 1. So we get that y is equal to 3 plus 2, which means y equals 5. And now the last step is to write our answer as an ordered pair. So since I have my x-coordinate and my y-coordinate, that means the answer is 1, 5. And so what that tells us is if we were to graph those two lines, 1, 5 is where they would cross, but we're able to figure that out without graphing. Okay, let's look at another example really quickly. In number 2, first question is one of the equations solved for a variable? And it is, and this is what I was talking about before. It does not have to be y. This one is solved for x, and that's okay. So that means we are going to take the y plus 3 and replace the x in the second equation. So I'm going to take out the x and put in y plus 3 instead. And then the rest of the equation stays the same. Plus 2y equals negative 6. Like terms here and here, 1y plus 2y makes 3y plus 3 equals negative 6. Now that both sides are simplified, I'm ready to start moving stuff. So I'm going to subtract 3 from both sides. 3y equals negative 9. Then divide by 3. So y equals negative 3. We are halfway done. Now that we know what y is, we need to take that and plug it into one of the original equations. I'm going to plug into this first one here. So I have that x is equal to negative 3, because that's what y was equal to, plus 3, which is 0. So x is equal to 0. Ordered pairs always go x first, then y. So the solution is 0, negative 3. Okay. At this point, if you feel ready to start the assignment, you can go ahead and fast forward in the video and just copy the notes down for number 3 and 4. If you don't feel ready, then you can watch a couple more examples. I'm going to go ahead and work these out here. So on number 3, y is the variable that's by itself, so we're going to take out y in the second equation and put in negative 5x minus 12. And a good habit is to always substitute in parentheses. So here's where my y was. So I'm going to start parentheses and put in the part from the previous equation, equals 4. The reason that these are really important is because that helps you that you need to distribute right here, and that's something that people commonly forget. The other thing is not to ignore the fact that this is a negative 5 that you're going to be distributing. So we want to watch for that. The 3x is not going to change. Negative 5 times negative 5x makes positive 25x, so now it's addition. And negative 5 times negative 12 is positive 60. And that's equal to 4. Like terms here and here, that makes 28x plus 60 equals 4. Subtract 60 from both sides. Use your calculators, guys, if you're the ones that are making errors just solely based on your subtraction, because I hate for that to be the reason that you're missing points. 4 minus 60 is negative 56, and then when we divide by 28, that actually comes out nicely. We get x equals negative 2. So now just think to yourself, once I know what x is equal to, what do I do now? Well, now I'm going to go up and pick one of the equations from the top. I'm going to pick this one. And I'm going to plug that in where x was. So negative 5 times x, which we know is negative 2, minus 12 equals y. This makes 10 minus 12, which is negative 2. And so again, write your answer as an ordered pair, negative 2, negative 2. There's your answer. Okay, so for number 4, I just want to show you a couple of things. If on number 4, the bottom equation had been on the top instead, 5x minus 3y equals 2, and x equals negative 2y plus 3, don't let that throw you off. These are the exact same problem. It's okay that the one where the variable is by itself is in the bottom. That doesn't change anything. We're still going to take out the x from the top equation and put this one into it. So I'm going to say 5 parentheses. Now we substitute negative 2y plus 3. And then the rest is the same, minus 3y equals 2. Distribute our 5. Negative 10y plus 15 minus 3y equals 2. And then we look to see if we have any like terms, and we do right here and right here. So we get negative 13y plus 15 equals 2. Minus 15 on both sides. Negative 13y equals negative 13, and you can see that this is going to come out nicely. So y is equal to 1. If it feels like I'm going too fast on the examples, don't forget you can put a video on pause until you kind of catch up and follow through. So if y is equal to 1, that means we now go back and plug into either of the equations. Since x is what I'm missing, I'm going to plug into this bottom one. So I'm going to say x is equal to negative 2 times y, which is 1, plus 3. Negative 2 plus 3. So x is equal to 1, and 1 is our solution. One more thing, I'm not going to work this one out, but I'll just show you how you would set it up, because this always throws people off. What if both equations were solved for the same variable? This doesn't change the process at all. All I would do is say, well, y is equal to 2x plus 5. I'm going to put that in for y in the second equation. So that would look like 2x plus 5 equals, that just went in here. So now I just have the rest, negative 5x minus 1. And then you would go ahead and solve it from there. So don't let that throw you off. Alrighty, you have an assignment to work on now. And remember that if you guys get everything done and have time, then you can have some free time at the end and watch a movie and play on your computers. So hopefully you're doing what you're supposed to be doing. See you guys later.